Welcome to Insight Builder channel, Large Language Model Automators, Python experts, and my dear friends. VLLM, rocket engine of LLM Inference, speeding up the inference by 24 times compared to Hugging Face transformers. What are we going to discuss in this particular video? The challenge that most of us face when it comes to large language models is threefold. First is the GPU resource. When you want to load or work with a large language model, you need to have a powerful GPU. There are varieties of ways to access the GPU. So you can have your own GPU resource in your laptop or in your server that is located locally, or you can hire or host the GPU in a cloud server and you can access it. The second challenge that arises is if you're going to use a cloud environment or the internet provided GPU resources, the GPU availability is limited, and also it is provided in a batched, it's provided in a on-demand basis. So if you are not going to use the GPU, someone else is going to use the GPU. So the demand and the availability of the GPU is the second challenge. Okay, so now somehow you manage to take care of the resource that is the GPU, and you have the GPU with you. And the final challenge is once you load the model is very huge and it takes a lot of time to provide the generation or the inference. Let us go to the browser. If you guys have seen the various videos that I have posted on the open source models, that is large language models, and you must have already come across various open source highly good performing models like Llama, OPT, MPT, and Bloom, etc. And these parameters, the models parameters are in 13 billion, it goes to 65 billion, and it goes to 176 billion in case of OPT. So all these models require a huge amount of GPU space as well as RAM. How to work with these models? One of the options that I was discussing is quantization, so 4-bit quantization and 8-bit quantization. So that is one of the ways. And also another way that is provided by default is reducing the bit size. So if it is going to be float 32, it can be reduced to float 16, that is B float 16, or another one option that is available. All these options are there, but none of these options actually talk about speeding up the inference. To speed up the inference to a level that we are going to see right now. So this is, okay, just a minute. This is the collab notebook that I'll be sharing with you over the GitHub repo. So don't worry about that. The description will contain the repo link of this particular example. And this particular example has been taken up from the welcome documentation of VLLM. VLLM is one of the open source libraries that has been introduced by UC Berkeley team. So I will talk about this in a moment, but before that, I have already installed VLLM and I have already installed FastChat. FastChat we are not going to use in this particular discussion, but I have anyway installed it. And I am trying to work with these four prompts, which is talking generic details like my name is the president of United States, and all this will initiate a generation. And the sampling parameters that I'm going to use is max tokens 50, temperature is 0.8, and top P is 0.95. So if you guys are not familiar with any of these parameters or arguments, I would suggest you to take a look at the documentation and also go through the NLP process, NLP documentations. After this, I am pulling the Facebook OPT 125 million model. So it's a small model. It's not very huge. It's a small model, and it can easily fit into the GPU. And this model is taking almost 13.5 GB of GPU space. So this is quite huge. This is a T4 16 GB GPU, and out of that 13.5 is taken up. Next is the interesting point. So what I'm going to do is, this is not the output. So What I'm going to do is I'm going to generate outputs based on these four prompts, and you will see it happens really fast. Yeah, so that is the output that you are going to get. So hello, my name is, so I'll zoom in a bit, and you see this is the first generation, and the generated text is, my name is Mika and I am a first-time pilot and I'm looking for so and so. And same way here, United States is warning United Nations and other international against the post-Islamic State threat. And capital of France is not a city, it's a republic. So here, the speed with which it got generated is possible because of VLLM. And VLLM is able to achieve this speed because of its new technology, it's called new algorithm called as paged attention. I am not going to go into the technicalities of what is paged attention. What I am more interested to show you here is that how the VLLM integrates with various Hugging Face models, how the high throughput serving can be used for your benefit, and how you can also use VLLM to create API servers. The point is very simple. So why will you want to work with large language models? You want to solve a problem, or make your customers happy, or create a chatbot, right? So if you guys are new to any of these things, you can create chatbot using Gradeo. So Hugging Face Gradeo. So you can take a look at these discussions that I have been having. You will get a very good introduction. What made me to create this video is this cloud chatbot Vicuna and chatbot arena. So this is one of the websites that has been hosted by LLMs, the large model organization systems. This company is part of UC Berkeley team, and they use VLLM, they use FastChat to host various models. And apart from that, they have also created something called a Skypilot, which can control and which can get you the necessary resources, the GPU resources that I was talking about. So basically, this video is actually talking about three things. So it is talking about VLLM, which can speed up your inference. It is talking about Skypilot, which can actually get you the necessary resource of GPU that you want from the cloud, and it can help you to host it using FastChat. All these three things have been open sourced by UC Berkeley team. And once you understand how to work with this, and you might be thinking, okay, how fast it can be. So here is a Vicuna 13 billion model, and this is hosted in one of their cloud infrastructures. And this cloud infrastructure background to this particular chatbot is VLLM. So I'm going to ask how Earth is made, and I'm going to send, and this is going to start the generation. So the idea here is the speed with which the generation gets created is phenomenally fast. So you see that the output is almost looks real time. It's not as fast as ChatGPT, but it is trying to reach to that level of coherence and as well as the speed. As you actually give more resource to this, it is going to be further faster. Okay, so this is one thing that I realized. So once I was trying to explore Chat Arena, then I immediately got curious that why Chat Arena is fast and what is running this Chat Arena. And that's when I went and explored VLLM, and I found that it's not just one model or two model. VLLM can support multiple open source models, multiple open source architectures. So basically, VLLM team has already created the necessary code for all these architectures. And you might be wondering, Kamal, the architecture that I am having is not in this list. So what to do? If that is the case, you can actually add a new model architecture itself, and they have provided the necessary code for you to do that. So the process you need to follow, everything has been given. And And assuming that if you don't understand or if you need a example for this, all you need to do is head to their GitHub repo. So once you head to their GitHub repo, one of the benefits of understanding how the things are being done, right, is that you can easily read how they have implemented the other LLMs. So if you go to their GitHub repo, so just a minute, let it load for a second, because give it a second. And in this GitHub repo, if you go to the VLLM, that is the actual repo where it contains all the necessary classes that VLLM creates. If you go into the if you go into the model executor folder models, you will see the various architecture that has been already implemented by VLLM team. And if you want to implement a new architecture that is from your side, then all you need to do is go into this architecture, understand how they've implemented this architecture, and then by understanding this, you can use to integrate your own architecture in this particular model. So even though they have given the documentation, I always prefer to work with the code examples. So this way you can do the things very easily. With the new model, you can whichever model you are going to plan, you can use this respective processes or the documentation that has been provided here, and you can implement your new model. So what happens in case of the VLLM? So let us go back to the discussion here. Let us go back to the Collab notebook. So here, as I was telling, that we are pulling the VLLM library. So VLLM library installs all the necessary background libraries like transformers and also the Hugging Face Hub connectivity, and it pulls the data from Hugging Face Hub only. And after it pulls it, then it goes through the LLM class. So this is the LLM class that has been that is inside the VLLM library, and then we are using that LLM class to initiate the model. Once the model is initiated, we use the generate method to generate the prompts, and using the sampling parameters that we have created here. And then once the generate as well as the sampling parameters have been defined, we can generate the output. And you saw the output for the 125 million parameter is quite fast. You might be wondering, but still 125 million parameters is pretty small. What other parameters or what other models can VLLM work with and can generate really fast? So what I had done was, you have to, first of all, before you want to load any other new models, you have to remove the model from the GPU. So you have to execute torch cuda.empty cache so that it can remove this model. This Facebook model that you loaded into the GPU has to be removed. So you see from 13.5 GB of GPU usage, now the GPU usage is 1 GB. So 1 GB by default will be used by the CUDA kernels. So be ready for that. That is one of the major challenges that I've been highlighting from the beginning, that even if you have GPU of 16 GB or 24 GB, equivalent amount of 2 or 3 GB of CUDA kernels will be loaded into the GPU for making these models work. Okay, so that is how you do it. And then I had tried couple of models, like I tried Mosaic ML, I tried Stability AI and Vicuna LLM. And you know what had happened is, most of these models, when I was trying, there were some or the other kind of an error when you work with VLLM. This is a deal breaker. So you might be thinking that when you look at other videos, or if you have come across the various documentation and the models that they say that it is possible, but when you try to load it in your environment, for an example, Google Colab environment like this, and if your GPU does not support, or if your GPU is not sufficiently having the memory. So for an example, what had happened is, let me show you what happens with Mosaic ML MPT. So I'm going to try to load this MPT model, and the moment I try to load, you see the error starts incurring. And the error is actually linked with, not actually the model itself, the error is linked with, see, you see this, the parameter, the type of type of the parameters has to be BF16 only. Okay, so the type of the parameter cannot be BF16 because it is supported with the compute capability of at least 8.0. In case of Tesla T4 GPU, the compute capability is less than 8. So what is the option? For this, VLLM has provided an option of changing the data type. So if you go into the LLM class definition, you can see that you can create something. Just a minute. So if you click on LLM and this LLM variable class declaration, if you click on the class declaration, you can see that you can just a minute. Sorry about that. You can see you can declare a data type. So instead of using BF16, you need to change the data type. So what kind of data type can we use? So if you scroll down, you can see that VLLM supports various other data type like float32, float16 and BF16 also. So let us actually try to change it to float16. So I'm going to create a variable. I'm going to create the parameter float16 and I'm going to load the model. So you see, one of the benefits of working with various open source models is that it's not about getting the things executed or getting the output. It's about learning the actual challenges that one or the other face. So now that is resolved, and now you see that I'm getting another one error, trying to initialize the default group twice. Why is this error coming? So basically, I have already initiated the Mosaic ML model, and also I have initiated Facebook model in the same runtime. That is why it is saying I am trying to reinitiate it. So all you need to do is go to runtime, and I have to say restart runtime. All these challenges are more important to learn rather than actually creating the generation. And why am I telling this? Okay. See, at the end of the day, all the algorithms are written by someone in the research institute or someone in very huge companies who have a lot of resources. But when we are using it as an application developers, our resources are minimal, but the resources that we have in our hand is our ability to think creatively and use the models and their capabilities to the best possible fashion. So that is why I always want to show what are the errors, what are the type of challenges you can solve, instead of actually going and searching in Stack Overflow and reading a lot of documentation. I just want to make your life as simple as possible. So when you're restarting the runtime, you don't need to install this pip installation because it will take a lot of time. Keep that in mind. You have to just import the LLM as well as the sampling parameters classes. It will get imported, and then you can define the prompts and the sampling parameters, but do not execute that particular command and directly come to MPT model, because we are going to try MPT model, right? We want to see whether we can load MPT model and we can generate, or what other kind of errors we get. So now you see that MPT model is starting to load. So initially, when I was trying to work with various models like this, I was facing the error, and I was not very convinced that the VLLM team is claiming that they can work on all these models, but I'm trying to work with GPU, that is T4 GPU, and I'm still unable to load these 7 billion models. And then I realized, okay, so I need to understand a bit further. And that's when I came across these kinds of errors, and I did my research. And you see one good thing, that both the bin files are getting downloaded in parallel. This is one of the new things that I realized. In case of transformers, if you are going to load the same model, it will sequentially download the bin file. But VLLM is fast, and VLLM is also used for, as I told, it is used in this chat arena. So if it is going to be used in this chat arena, it's not one chat arena. You see the entire. Okay, sorry to cut in. I have moved to the new window here, and we were discussing. You remember that I was showing you how the chat arena is using Vicuna 13 billion to create the generation. So you see, I asked how Earth is made, and it has given me a full coherent information on how Earth is created. Apart from that, you can actually load various other models that is available here. And all these models at the backend is actually using VLLM. This is what actually made me to search further that, okay, what exactly this VLLM library can do and what other additional things that UC Berkeley team had created. And that led me to the understanding of the Skypilot. I'll be trying to, because currently Skypilot is best used if you're going to get allocation to the GPU resources. And all the, AWS, GCP, Azure, even Samsung's cloud premises, all these cloud premises don't have free access to their GPU runtimes. You have to give some kind of, you have to start the paid billing processes, and then only you will be able to access it. At this moment, if you guys are not ready to give an investment of that type, I would suggest that take a look at the Google Colab environment, understand how it works in Colab environment, and then once you are confident that you want to invest and start to learn, then you can work with Skypilot as well as the FastChat. Okay, now you see the my runtime has crashed. So let us view the runtime. So why my runtime crashed? So these are all various kinds of issues that comes into picture. And here you see that the error that I'm facing, just a minute. The error that I'm facing here is because of the model size. So the model size here is almost 10 GB, 10 plus 3.3. And apart from that, there will be additional files. So it comes up to 14 GB of space. Apart from that, as I was telling, the CUDA kernel will also load a couple of its own programs to run. And this T4 GPU has 15 GB of useful VRAM. If I load 14 or more than 14.5 GB, the system will crash. So basically, MPT model, we cannot use it inside the GPU T4. Inside the GPU T4. So next, okay, so it crashed. So now what shall we do? So then I had further tried to explore, and I found that we can try to work with Dolly V2 3 billion model. So this is another one model. There are lots of models that is supported by the VLLM. So I did explore some more. So then I again tried this and defined the prompts. But this time, instead of running MPPT or Stability or Vicuna, I am directly going and downloading and running 3 billion Dolly version 2. And also ensure that you are properly creating the data type float 16, and then you start the process. And then you can see so here this model is actually much smaller. So this model can easily load into the GPU VRAM, and you can do the inference. When you compare it to the regular inference, so I would actually give an option for you guys to practice it by downloading the transformers pipeline and comparing it, how fast the regular transformers inference is and how VLLM inference is. So that will give you an idea and know-how of what exactly is the benefit of VLLM. I don't want to compare it, because comparison is something that I want you guys to do it and you guys to experience and explore it. The more you try to compare, the more you try to learn about the internals of the models, the faster you will be able to understand how the things are working. So once I load this model, I'm going to just use this Dolly LLM. So Dolly LLM is the variable that I have used for LLM instantiation, and then I'm going to generate the text, and you will see that it is equally fast. So the point I am again making is the challenges the VLLM library and the associated libraries like Skypilot and FastChat solve. So once you are able to load the model like this in T4 GPU, then you can actually start serving the model, because you want your customers to use it, right? And how are you going to make your customers to use it? The best method is to use an API endpoint. VLLM has provided the methods for taking this model that you have instantiated and serving it over the internet. So if you go to the documentation, and if you go to the distributed inference and serving, so you see the documentation is also pretty simple. So they are not talking a lot about what is going on, what is their algorithm, etc. So they just want you to use the model and get your problem solved. Here you can see that you can, if you want to have multiple GPUs and if you want to use Ray, you can use a Ray library also. And if you are planning to just do the inference, you can use this particular VLLM entry point API server. So if you run Python VLLM.entryPoint.API server inside the repo, so you should clone this repo first. You should clone this clone this VLLM repo, and then from inside the repo, once you are inside this repo directory, then you need to run Python VLLM entry point API server. And if you can tell the model name and the tensor parallel size, it will initiate a API server for you guys. In the backend, it is using Fast API, if I am not wrong. Do check it out. And now I think it has been done, and you see that the Dolly model loaded without any challenge. And if you go to the RAM, you will see the RAM is almost 13.5 GBs has been already used, that too for 3 billion model. And here I am trying to load a 7 billion model. Obviously it will fail, right? And so that is how, so you see the output has been already created, and you can also see the output is actually a coherent output. It's not just this. So here I have only shown you the data type parameter and also the model parameter, but this LLM model class has a lot of other parameters that you can use. So apart in one of the important parameters that I want you guys to take a look at is the KW args. Inside the KW args, you can actually change the way of getting the next word. So if you go down into the discussion, just a minute. Okay, so anyway, so in this particular discussion, it's not directly available. Just let us go to the view source. Just give me a second. See, most of the time what happens is, instead of reviewing the documentation, it is always better to review the code directly. And the code has this kind of doc strings that provide you a lot of information that it is not available in the documentation. So as you scroll down, you can see that various types of initiation that they have done, and as you go down further, okay, I remember where I wanted to discuss with you guys. So let us actually go to the sampling parameters. So the point I wanted to say is available in the sampling parameters, not in the LLM. So if you go to the sampling parameters, let us go to the sampling parameters class, and in sampling parameters class, apart from the max token, temperature, and top P, you will have various other parameters here. Like the most important is using beam search. And if you're going to use beam search, you will have a very good coherent output. Okay, that is how the decoding happens. So VLLM takes care of both encoding, generation, and decoding for you. It's like the transformers pipeline. If you guys are new to transformers pipeline, I would suggest that take a look at these videos, because I cover the basics of transformers pipeline both in vision and NLP in these two videos. Once you understand these things, then it will be much easier for you to understand more complex algorithms like VLLM and the libraries that VLLM, Skypilot, and FastChat. So I believe that you guys had some, a good introduction about what exactly happens in VLLM, how to work with VLLM with various different models, and how to handle the errors. Because the errors that you saw is the most common errors that you will face when you start, experimenting with VLLM. I believe that it will be helpful for you if you start comparing VLLM with the transformers pipeline and see how the output is. And do share this content with others, because right now most of the industry is facing the challenge of getting the actual inference at the right time at high speed, because customers don't wait. They cannot wait for a long generation. ChatGPT you go to ChatGPT, you start chatting with it, and you are ready to spend time there, because you know that others are already, having the outputs and they are doing great things with ChatGPT, and so you want to also wait there and check how your output is. But in case of open source models that you are going to host, such a kind of a benefit will take time. So initially you need to have very high speed of generation, so people get hooked to your model. So with that said, I would like to leave this video with